Hello, algebra students. Mr. Lawrence here. I don't know if you can hear that echo, but I'm hearing it too. Hopefully I'll have to do a restart or something. I'm going to go ahead and try and do this. But anyway, I'm on a special site here. You see this www.desmos.com/calculator. This is a free online graphing calculator that I've talked to you about, and we're going to do some graphing practice, but I'll show you how it works really quick. You just tap in that little box, and then let's say you want to graph the equation y equals 3x minus 6. That's in slope-intercept form, right? You should have a y-intercept of -6 and a slope of 3 over 1. Well, you can zoom out so that we can see everything. And there we go. It looks like my y-intercept is at 0, -6. See that? And if I count slope, I can go up 1, 2, 3, and write 1. Look at that. I hit the line. 1, 2, 3, write 1. And it even found me my x-intercept. I don't know if you noticed this, but it was changing as I change the equation. Let me change it to say, oh, look, now it's just y equals 3x. There's my y-intercept. But let me change it to say plus 4. And sure enough, the y-intercept moved up to 4. So it's pretty cool. I'll use it here in a second. This is going to be the review video for solving systems. So let me go to my work here. All right, I have two equations for you. Y equals x minus 1 and y equals -3/4 x plus 6. They're both in slope-intercept form. So I'll do the red one first. I'll find the y-intercept, which is at -1, right? And the slope is 1 over 1. So I'll rise 1, run 1, rise 1, run 1, rise 1, run 1, and then I will draw that red line. And let's see here, it's going to kind of go like that, right? Okay, so get an arrowhead, we'll make them thinner, and we'll make him red. All right, now I'll do the green one. Again, the y-intercept is pretty simple. It's going to be at 0, 6. And then the slope is down 3, 1, 2, 3, right 1, 2, 3, 4. Look at that. I know where they're going to cross. They're going to cross at the point 4, 3. Yeah. But let's go down 1, 2, 3, 1, 2, 3, 4. And I will draw that line. And so it's going to look something like this. Make him green, even though it's not easy being green. All right, now I'm going to go to that graphing calculator and show you how to get the system. All right, this is my first time using it for a system. I used it with the honors kids, but the first equation was y equals x minus 1, I believe. Yes. Now I need a new equation, so I'm going to hit this return, this enter button, and then I had y equals, now I'm not sure how it's going to perceive -3/4 because I've never used it, so I'm going to put the -3/4 in parentheses. Ooh, it turned it into a fraction. I do like that. Now let's see, how should we get over? I need an arrow button, and there we go. We need an x, and what was it, +6, I think? +6. That's very cool. Now look at this. You've got 0, 6 is the y-intercept of the blue one, 0, 1 is the y-intercept of the red one. It's not showing up because the red one wasn't highlighted. Now it will. There's the x-intercept. Highlight the blue one. There's the x-intercept. Look at that. It does show the point of intersection, the solution. And remember, when we're solving a system of linear equations, we're looking for the place where the two lines cross. It doesn't have to just be lines, but these are going to be linear situations. All right, here's a second one. And I believe I can type the equation in that way, but we've got to make sure we know how to do this by hand. So first one's in standard form, so I'm going to go A, B, C. Easy as 2, -5, -5. And so my slope is going to be the -2 over -5, which is 2/5. Okay, the y-intercept, I think, will be the easy one to find, or not the easy one, but the pretty one to find. So for the y-intercept, how do I know? Because -5 goes into -5. I'm going to plug 0 in for x. So I'm going to get 2 times 0 minus 5y equals -5. And then -5y equals -5. Y will equal 1. So the y-intercept is at 0, 1. And so I'll plot 0, 1. And my slope was 2/5, so I'll rise 2 and run 5. Rise 2 and run 5. I can even go down 2 and left 5. Down 2 and left 5. All right, so a nice little graph. Oops, it looks like I'm off a little bit. See if I can make that a little prettier. Get those points a little bit better. All right, properties. And we'll make it red. Okay, now the blue one is in standard form as well. And so I'll have to find A, B, C. Don't you ever erase your work. I'm just doing it for space here on the airliner. So my blue one, A, B, C are 12, 10, negative 70. All right. Let's see here. My slope is going to be negative 12 over 10, which simplifies down to negative 6/5. Looks like the y-intercept is the easier one to find, or the prettier one. So I'll plug 0 in for x. So I'll get 12 times 0 minus 10y equals negative 70. And when I solve that, I'm going to get y equals 7. So the y-intercept is going to be 7. And the slope is down 1, 2, 3, 4, 5, 6, and right 5. Like that. And down 1, 2, 3, 4, 5, 6, and right 5. And so let's get that line going on. It doesn't look like they're going to cross at a pretty place. No, that can happen. That shouldn't happen on your take-home test. They should all come to a nice little intersection. But since we've got this graphing calculator, I want to go ahead and see what it'll tell me. Now, it'll probably only give me a decimal approximation. It won't be exactly the answer. So what do I got? 2x minus 5y equals negative 5. So I'm going to clear that out and go 2x minus 5y equals negative 5. Oop, I've got too many equals here. Let me get rid of all this. Sorry about that. There we go. And this one, I know it was 12x. It must have been plus 10y. I think it equaled negative 70. Oh, do I have a mistake? Yeah, I think I do. Hold on. It's plus 10y. Ah, there's my mistake. I made a mistake when I graphed it. See that? It should be negative 7. Right? I went a little too fast. That should be plus. Okay? So that changes everything over here. I do apologize. Takes my y-intercept down to negative 7. My slope is still negative 6/5, so I'm going to go up 6. 1, 2, 3, 4, 5, 6. And then left 5. And look at that. They're going to cross right there. And then I'm going to go up 1, 2, 3, 4, 5, 6, and right 5. And the cool thing is, because I use the same slope, the same line will match. I don't have to redraw it. So the graphing calculator was a great tool to help me check my work. And look at this. They're crossing at negative 5, negative 1. And that's exactly where I have my graph crossing. So I'll put this in here. Negative 5, negative 1. All right, one more review. And we've got x equals negative 2. Well, if you haven't figured that out yet, when x equals a plain old number, it's a vertical line. Okay, you can go standard form if you want, or you can think about a table. What does x have to be? Negative 2. Y can be anything you want it to be. This is going to be a vertical line going through negative 2. So it's going to be like that. X equals negative 2. All right. Properties. And let's see here. This is the red one. There we go. Nice and pretty. Looks like it might be off a smidgen. That's pretty close. Okay, now this one, again, is in slope-intercept form, but if you want to think about it a table way, it might be easier. You know, you can do the y equals 0x plus 5 if you want, or you could say y has to be 5 in every occasion because it says y equals 5. and then maybe I'll put 0, 1, and 2 there. So 0, 5 is here, 1, 5 is there, and 2, 5 is there. It's a horizontal line. Whenever it says y equals just a plain old number, you get a horizontal line. And you can tell that these are going to cross at this point here. So the solution is going to be -2, +5. And there you go. Now the cool thing is these online graphing calculators, this one I found, can graph a vertical line. The TI-84s are limited, they can't do that. So the first one was x equals -2. Yep, and see it really likes that. Okay, and then the other one was y equals, I think it was 5, right? And there you go, and look, it even changed colors for you. And see they're crossing at -2, 5. All right, that's the video for today. Mr. Laurence signing off. Have a good night, everybody.